Hi everyone and welcome to my channel. As you remember, in the last video I built a 3D printed 6 degrees of freedom robotic arm, this one. And we already learned how to control it using Arduino program. And this control through Arduino program, it's very precise, very nice, but a little bit complicated. Thus, I decided to make an Android application to control this robot. And the control is gonna be made via Bluetooth connection. But before we continue, if you're new to my channel, please consider to subscribe to my channel, and also please consider to support me on my Patreon page or via PayPal. All the links in the description. Let's get started. In order to control the robot arm via Bluetooth connection, we need to connect Bluetooth module to the Arduino board. And so this is RAM's board and this is Bluetooth module which I connected over there. So this is this module. It's Groove Serial Bluetooth version 3.0. But actually any Bluetooth module which have HC 0.5 Bluetooth module will work. So there is 4 wires from this Bluetooth module, and 2 of these wires is just ground and plus 5 volt, which is connected on the board, and 2 other wires, white wire and the yellow wire, is receiver and transmitter for the Bluetooth module. So you see it's RX and TX. RX it's receiver and TX is transmitter. So transmitter of this Bluetooth module is connecting to the receiver of the serial port on the RAM's board. There is a lot of wires, it's difficult to see. And this is simple schematics how it's connected. So this is this Seed Groove Bluetooth version 3.0 module, and 2 wires is connected just to the ground and plus 5 volt. And another 2 wires for TX and RX is connected to the RAM's board. So TX connected to the RX, RX connected to the TX, and this corresponds to the serial 1 port, to the digital pin 19 and digital pin 18. The idea of using smartphone to control a robot went to me through this website from this guy, How to Mechatronics. He also has his YouTube channel. And here he using Arduino robot arm, this one, and he controls this robot arm using smartphone application. So I basically used his approach and adopted it for my robot arm. So now let's go to the Chrome. This is I already opened the GitHub page of the project. So let's go to the view code. Now we need a software. In the software folder we need a Bluetooth folder, and we need this file desktop version over here. And now we can download it. Okay, open. It detects a risk, I don't know why. Still install. Install. Blah blah blah, I don't believe you. Okay. And you see this nice logo. Done. And now let's go to the desktop. And you see that we have this nice application. Ta-da! So now let's switch on the robot. And now we can connect to the Bluetooth. Connect. And I know that it's this one. Okay, now it's connected. So first thing which we should do is we should enable motors. So with this button, long click. And you hear the motors. And now, for example, we can move the axis number 1. Like go to the 21 degree. Go. Aha, it moves. Go minus 35 degree. Go. Nice. Okay, go 30 degree, 0 degree back. Okay, now axis 2, 0 degree. Axis 3, 0 degree. Nice. Let's save this position. Axis 5, let's put it downward facing. So it's 90. And now let's run all these positions together. We just program it through the smartphone. Nice. Love it. Cool. And now we can disable it. Done. And this is to reset all the saved positions. Reset. Now let's see how we can build an Android application to control this robot. Why I'm using Android and not iPhone? Because Android is supporting this Bluetooth and iPhone unfortunately does not support this Bluetooth. In order to create the Android application, I use MIT Inventor. Why I use this application? Because this application is very simple and it's free, but unfortunately it's a little bit limited. In order to use this App Inventor, you need to have the Gmail account, and afterwards you can log in on this website and you can start a new project. So I already built this project. So as you can see, this is the first screen and the only screen. And to this screen you can drag and drop different components like buttons, labels or sliders. And I already put all of them here. And how it's arranged, that at the beginning I have the part which is responsible for the Bluetooth connection. And by the way, I also put a Bluetooth client over here. It's a so-called non-visible components. So this is responsible for the Bluetooth. The first button allows you to select the appropriate Bluetooth device. Here it shows the status of the Bluetooth connection, and this button is just to disconnect. After there is this part with a lot of different sliders, and it's composed like this. So first of all, let's look at this part. This part corresponds to the axis number 6. There is a slider over here with which you can select the angle of the joint, and this angle is going to be shown here. And when you're ready with your selection, when you're happy with your selection, you can ask robot to go to this position by pushing this button Go. The same is for axis number 5, axis number 4, axis number 3. This is, by the way, the folded position. Axis number 2 and axis number 1. Afterwards, there is this part, which is responsible for the speed selection. So here you can change the speed of the motion and send it to the robot with this set button. After there is a set of the final speed. In the 99% of the cases it stays at 0, so most of the time you don't need to touch it. And afterwards there is these 5 buttons. So enable and disable buttons, this is to enable or disable motors or drivers. Save button is to save the current position into the memory of the robot. And when you push save button once, you will have here this is actually the counter of how many points, how many position was saved. So the procedure is like this. First of all, you should go to the sum position with these sliders and these buttons. And when you are happy with this position, you can choose the speed. You can choose the final speed, which usually stays at 0. And when you're happy with this position, you push the save button. And like this, robot remember this position. Like this, you can save up to 50 different positions. And when you press the button run, what is going to happen? That robot is going to move through this position. So first of all, it's going to position number 1, position number 2, 3, blah, 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 etc., till the end. The reset button you need to use when you want to erase all these positions. So this is the layout of the program, and now let's see the program itself. For this we need to go to the blocks, and here the entire program. So we can zoom in, like for example on this part, and this part is basically responsible for the Bluetooth. This part creates a Bluetooth list from which you can select a Bluetooth module which corresponds to this robot arm. This command will connect a Bluetooth client to this Bluetooth device. This is clock. Actually what it's doing here, it's check if Bluetooth is connected or not connected, and it shows the corresponding message in status, in the Bluetooth status. This is a button for Bluetooth to disconnect. So when this button is pressed, Bluetooth client disconnect. This is a part for the errors, Bluetooth errors. And now this part corresponds to is responsible for slider for the axis number 6. So when you change the position of this slider, and if Bluetooth client is connected, in this case the label is going to be changed to the value of this of the position of the slider. So when you push the go button, the program sends command to the robot, and it sends this text which consists of 2 parts. S6 we just say so this is the position for the axis number 6, and afterwards here is the value of this position. So basically this is the value which shown in the label. And there is the same part for the axis number 5, the same part for the axis number 4, axis number 3, axis number 2, and axis number 1. This part sets the speed of the robot. Afterwards, there is 2 buttons for the enable and disable. So basically when the enable button has a long click, what happens that it sends via Bluetooth the command enable. Disable button, after the long click, it sends the command via Bluetooth disable. Run button sends the command run. This is a slider for the final speed. And when you click save button, what happens that it sends command save with the final speed. And also it changes the counter for the position from 1 to the 2, or from 0 to 1. So it's actually basically it adds 1 to the counter of the position. And the resets button sends command reset to the Bluetooth, and also it set the counter of the position at 0. And this is basically entire program. Now let's look at the Arduino program. So I created this new file, and it's basically the same program as before with some modifications. So first modification is over here. So I added some additional variables here, like data in these positions. This is future positions. I added current speed and current final speed, and also index. This index corresponds to the robot positions. And this is different arrays to store the joint values for each saved position. I use the serial one for the Bluetooth connection, so here I initialize it. And here is the main program. So first of all, what I do, I check if there is something in serial one port, and if there is some value there, I store this value in the data in, and afterwards I look at this value. Like for example, if this value is equal to enable, so if someone send the command enable through the Bluetooth, in this case it will enable these pins, and like this it will enable motors and drivers. The same for the disable. Now if the command which sends through the Bluetooth starts with S6, in this case it means that this command is going to move the axis number 6. So I look what is number after this SX, and this number is stored in this data in S. Afterwards I convert this number to the floating number, and this is a future position. So I have the joint initial position, it's a current positions, and joint final position, it's a current positions, but for the axis 6 it's future positions from here. And afterwards I apply go straight line to move the robot. The same for the axis 5, axis 4, axis 3, axis 2 and axis 1. With this part I set the speed. If the save button was pressed, in this case I receive the command save, and I do this. So what I do, I basically extract from this command the final speed. First of all, use initial speed as a previous final speed, and afterwards I calculate the new final speed, and it's gonna go to the final speed here. And afterwards I use the joint values, like current position values, and I store them in the joint with a certain index, and afterwards I increase this index. And if the button reset was pressed, in this case index is just equal to 0. For the run command, what I do, that first of all I go to the initial position, to the position with the index 0, and afterwards we do this loop through the indexes. And now in this loop I'm going from the position with the index I to the position with the index I plus 1. And I do this loop. And this is basically it. Here my GitHub page, and I already put all the files here. So if you will go to the software, you will see that there is a folder Bluetooth, and inside this folder there is these 3 files. The first file is a file for the Arduino, so this file should be put on the Arduino Mega of the robot. This file is the file which opens the program for the MIT Inventor. And this file is a file with the smartphone application, and this file you can install on your Android smartphone. So basically you need this file to be installed on the Arduino, this file to be installed on your phone, on your Android phone, and this file you don't really need, you only need if you want to modify this application. There is also some strange thing that when I install this file to my smartphone, it says that there is a virus on this file, but I found that this is kind of common program with MIT Inventor, and I don't think that there is any viruses. At least my phone is still working. Now let's see how it works. Let's try this one more time. So I will close this program, just to start from the beginning. So open it again. Now I can switch on the robot. First of all, need to connect Bluetooth. Done. Enabled. Axis number 2. Axis number 3. Let's save this as a position number 1. And this is gonna be the next position, and let's save it. Let's save this too. Save this point. And save this point. So as you saw, we moved one axis after another. But when I push the run button, what is gonna happen is that it's going to move between these points, and it's gonna move all the axes together. So it's not moving one after another. It actually goes from one point to another point in the most, or one of the most optimum way. So let's see this. Done. Perfect. This is super nice. I like this. Simple and very interesting and very efficient. Disconnect. This is so nice. We can program the robot using only smartphone. One of the main disadvantages of this program is that the sliders are not very precise. Like, for example, now the position of axis 2 is 0.495, but the next value which I can put is like 2.6 degrees. 0.5, 2.6, and I cannot put anything in between. And the difference, this is 0.5 and 2.6. Look at the robot. You see? 0.5. But this is the disadvantage of this software, and I cannot do much about this. So I should use instead of MIT Inventor some other program to make this Android-based application. And the main advantage of this program is that it's super fun, super easy to use, and I think it's a nice experience. Thank you for watching this video till the end. Today we learned how to control robotic arm via Bluetooth connection using smartphone application. All the files is on GitHub page, so you can go there, download these files, use them, modify them, or do whatever you want with them. I would like to say a huge thank you to my Patreons. Here are their names. Thanks to them I was motivated to build this project, and thanks to them I will build another project. So if you're new to my channel, please consider to subscribe in order not to miss this and other amazing projects. And also huge thank you to the people who support me via PayPal link. See you next time.